Problem 4.15. Two links AB and DE are connected by a bell crack as shown. Knowing that the tension AB is equal to 720 newtons, determine the tension at DE and the reaction at C. Okay, first we solve for the tension at DE. We can solve it by using the equation of the moment at C. So moment at C is equal to 0, and using the force at AB, which is equal to 720 newtons times the distance 100 millimeter minus the force DE and the distance 120 millimeter. Equating that, we will get this one, and so FDE is equal to 5/6 FAB. We know that FAB is equal to 720 newtons, so we simply multiply 5/6 times 720 newtons. We get FDE is equal to 600 newtons. Next, we go to B, which is to find the reaction at C. Finding the reaction at C, we know that there is an X component and Y component at the moment C. So we will use the formula, the summation of force at component X is equal to 0. Getting the component X of FAB, we know that -3/5 times the force FAB plus CX is equal to 0. Equating that, we transpose this one to the other side, we get 432 newtons for CX. Next, we get the total force at Y component. We use -4/3 times the force AB, which is equal to 720 newtons, plus the component CY at C and 600 at D. We get 1,776 newton. Okay, so now we have the X and Y components for the moment C. We can get the C. We use the square root of CX squared plus CY squared. We get C is equal to 1,252.835 newtons. So this is the force. Next, we get the angle. To get that, we have known that CY and CX, we have the C in between of those. We set the angle into alpha. So using cotangent, tan inverse CY over CX is equal to 69.829 degrees. So the final answer would be 1,252.835 newtons, and the angle would be 69.828 degrees.